going to go through the notes for 5.4, modeling and optimization. The first thing I would like you to do in your textbook on page 224, I want you to copy down the strategy for solving max-min problems. This has a series of steps that you should follow anytime you are trying to go through and solve a word problem where you have to find the maximum or the minimum given some sort of set of conditions. So again, page 224, make sure you copy that down, look over it. Contact me if you have any questions about what those actual steps are. And that brings us to our first example. We're going to find the two numbers whose sum is 20 and whose product is as large as possible. So notice product, that means multiplication. So large as possible means we are going to maximize that. We are maximizing some type of multiplication problem. So it does tell us that we have these numbers, they have to have a sum of 20, which means one of the numbers would be x, the other one is going to be 20 minus x. When you take those two terms and add them together, you end up getting 20. So x is going to be my first term, 20 minus x is going to be my second term, and I want to look at the product of that. So the product, and I'm going to call that P of x for product, is x times 20 minus x, and that is actually going to equal 20x minus x squared. You could leave your product as x times 20 minus x, but then when you take the derivative, because remember when we're maximizing and minimizing, we have to take derivatives, you would have to use the product rule instead of just and I'm blanking on the rule name, but the rule where you bring down the exponent and multiply by what's in front. So I'm sure that will come back to me what the name of that rule is. But it is a little bit easier to take the derivative of P of x whenever it's in the 20x minus x squared format. So our derivative, P prime, is going to be 20 minus 2x. And again, when we're maximizing, you're finding your critical values. There's nowhere that this derivative does not exist. So I do have to set this equal to 0 and solve. And when I do that, we get that x would have to be 10. We can check that, and we can check to make sure that 10 is actually a maximum and not a minimum by doing a number line. So if I pick something that is less than 10, let's say, 1, and I plug it into the derivative, I am going to get a positive value. If I take something that's bigger than 10, like 11, I am going to get a negative, which means it is going up and then coming back down. So if I check that in P prime, which means it is going to be a max at 10. So we do have this max at 10, which means the x value is 10, and the 20 minus x value is also 10. So the two numbers who give you that sum the sum is 20 and the product is as large as possible, the two numbers are both 10s. Next example, we have a rectangle that we're inscribing under one arch of the sine curve. We want to know the largest area the rectangle could have and what the dimensions are that give that area. So if we have our sine curve here, we're just doing one arch of it. So at 0, sine is 0. This is going to be my pi over 2, and there's my pi. So at pi, I am back down at 0, and at pi over 2, I'm going to be up here at 1. So this is going to come up and come back down. One of the things that can make these types of questions difficult is being able to draw the problem and set it up. So we're drawing a rectangle. I have a rectangle that is underneath the sine curve. I need to know the height and the width of that rectangle, or the length and the width, however you want to state that. We cannot put numbers to this. We do need to use some type of expression in order to come up with whatever the dimensions are. We are trying to find the largest area, which means I am going to be multiplying the length and the width together and taking a derivative. So I'm going to start with this point here on the left-hand side. I'm going to say that that x value is x, which means this point up here is the ordered pair x and then a of x. So x, a of x. Now actually, instead of writing a of x there, because I know what this curve is, it's actually, yeah, that wouldn't be a of x. This curve is sine. So I would take the x, plug it into the sine of x function, which means this point here is going to be sine of x. This height then, if I'm looking at what this height is, this height is sine of x. So the height of my rectangle is sine of x. That's the first thing that I can use for my area. So sine of x times whatever my length is. This distance here is x. This distance here is x. Because of the way that sine is, the sine reflects, this would actually split my rectangle in half, which means this distance also has to be x. So if you were taking the whole distance here, this whole length of pi, and you're subtracting out an x on the left and an x on the right, that leaves you with this distance being pi minus 2x. Because again, you have an x on each side, the whole distance from the origin to where it crosses the x-axis again is pi, and you're subtracting out x's on each part. So this is going to be my formula. It is, the area is sine of x times the quantity pi minus 2x. Now with this one, I would not suggest distributing the sine of x because you're still going to get sine of x times negative 2x for the second term. It's still going to require you to do the product rule to take the derivative. So you might as well just leave it like it is and then go ahead and let's drive this. So we have the first times the derivative of the second. Well, the derivative of pi is 0. The derivative of negative 2x is negative 2. Plus the second times the derivative of the first, which is cosine of x. So we take the derivative, we set it equal to 0. It is not possible to solve this equation using just algebra. You actually have to use a calculator to see what the solution is to this. Now keep in mind, our x value actually has to be lower than pi over 2. So whenever you are looking at what the value is, where this is equal to 0, where this crosses the x-axis, you do need, because it's going to cross at multiple places, you want to look in between 0 and pi over 2, and you're actually going to get for that 0.710. Again, I don't have my graphing calculator updated with my new computer yet, so you'll have to take my word for that. If you do need help, please contact me. I can go over that through a Teams meeting using the actual calculator or using Desmos. You can use that as well. So now we need to know, let's see, what is the largest area and what are the dimensions? So now that I know the x value, I can actually plug this back in and find the area of 0.710. So I'm plugging it in for the sine of x, for the x value, plugging it in for the x here with the minus 2x, which gives me an area of, and I don't actually have this to 3 decimal places, I only have this to 2. It's 1.12, and it doesn't say what the units are here. So I'm going to go with units squared, that's a 0.65 by 1.72 rectangle. So notice it didn't actually ask me what was the value of x. It said, what is the area? And then what are the dimensions of the rectangle? So with these questions, you do want to make sure that you are answering the question that is being asked, not the one that you think is being asked, because that can be different depending on your situation. I'm going to break here because the next two questions are very involved. So they are going to be in a separate video. Please look back over this and watch the book video as well, because it goes through a lot of the helpful hints and things to solve these types of questions. And if there's something that doesn't make sense, please reach out to me so I can answer any questions that you have.